Hello, and welcome to part 2 of this video tutorial on how to name alkenes using IUPAC nomenclature. We're going to look at some larger molecules with alkene double bonds and examine how to name structures that also show cis-trans isomerization. First off, we'll look at this structure. Examining our molecule, we need to find the longest continuous carbon chain that includes the highest priority group. For this structure, this is the alkene functionality. In numbering the longest chain, we make sure to give the alkene group the lowest possible carbon number. The alkene in this 3-carbon structure is first encountered at carbon 1. This carbon number is placed in front of the parent name. Based on the length of the carbon chain, the parent, if this were an alkane, the name would be propane. To change the name to show that this is actually an alkene, we drop the A in the ane suffix and replace it with E to make this an ene ending. The only substituent on this parent chain is the bromine, which is located on carbon number 1. However, bromopropene is not the complete name of this compound. This alkene molecule displays a unique type of geometric isomerism known as cis-trans isomerization. For this to be possible in a structure containing an alkene, there is one set of criteria that has to be met. When looking at each carbon of the double bond, the two groups of atoms that are attached to the alkene carbon must be different. This goes for both carbons involved in the double bond. In this example, we look at one of the 2 alkene carbons and what is attached to it. For this first carbon, there is a methyl group and a hydrogen directly bonded. These 2 groups are different. On the other carbon, it has a bromine and a hydrogen directly attached. These 2 groups are also different. Since both alkene carbons have different groups attached, this molecule has 2 isomer configurations possible. Next, we decide which of the 2 groups attached to each carbon on the alkene is the higher priority. The group with the higher priority is the one with the greater molecular weight. For the first alkene carbon we looked at, the methyl group has a higher priority compared to the hydrogen, since the molecular weight of a carbon atom with 3 hydrogens is greater than the weight of just 1 hydrogen atom. For the second alkene carbon, the bromine atom has a much higher molecular weight compared to the other group, which again is a single hydrogen atom. When a molecule has a cis configuration, the 2 higher priority groups reside on the same side of the alkene double bond, while in a trans configuration, the 2 higher priority groups are on opposite sides of the alkene double bond. Since this molecule has the higher priority methyl and bromine groups on opposite sides of the alkene double bond, the name of this compound would be trans bromopropene. Let's try looking at another molecule. Examining our molecule, we need to, of course, again, find the longest continuous carbon chain that includes the highest priority group. For this structure, this is the alkene functionality. In numbering the longest carbon chain, we make sure to give the alkene group the lowest possible carbon number. Here we have a 6 carbon long chain, and in numbering from the left, we can give the alkene group a carbon number of 2. This carbon number is placed in front of the parent name. Based on the length of the carbon chain, the parent, if it were an alkane, the name would be hexane. To change the name to show an alkene exists, we drop the A in the ane suffix and replace it with an E to make it an ene ending. Placing the carbon location of the alkene in front of the parent, we get 2-hexene. The only substituent on this parent chain is a methyl group, which is located on carbon number 3. In adding the name of this substituent in front of the parent, the name becomes 3-methyl-2-hexene. Before we decide if this is the final name of the compound, we check to see if there is cis-trans isomerism in this alkene. So we look at the groups attached to each carbon in the alkene bond. Looking at carbon 2 of the double bond, we have 2 different groups attached. One is a methyl group, and the other is a hydrogen atom. The other carbon in the double bond, carbon 3, has 2 different groups attached as well. One group is a 3-carbon propyl chain, and the other is a methyl group. So to assign cis or trans to this molecule, we decide which of the 2 groups has the higher priority. At carbon number 2, the higher priority is the heavier methyl group over the single hydrogen. At carbon number 3, the higher priority group is the heavier propyl group, which has 3 carbons and 7 hydrogens. This has a higher molecular weight than a methyl group with 1 carbon and 3 hydrogens. When we look at how the 2 higher priority groups are positioned around the alkene double bond, we notice they are located on the same side of the double bond. This would be assigned as a cis isomer. So the complete name of this compound is cis 3-methyl-2-hexene. This is the end of part 2 on alkene naming. Be sure to check out part 3 covering other types of alkenes.